Okay, in problem 1, we're supposed to find the derivative by using the definition of the derivative. You'll be asked to do a problem like this on your test, at least one. And to do this, we need to use the definition, which is right up here. The derivative of f is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So first, let's find out what this f of x plus delta x would be for problem number 1. So we're doing problem 1, f of x plus delta x. Well, if f of x is x squared minus 2x plus 3, to find f of x plus delta x, we're going to substitute the expression x plus delta x into the function everywhere where we see x currently. So f of x plus delta x will be x plus delta x squared minus 2 times x plus delta x, and then plus 3. So you can see this function is just like it was before, except everywhere we see x, it's been replaced with x plus delta x. And of course, f of x is just the function as it is. So let's go ahead and plug in and find the derivative. According to the rule, f prime of x is going to be equal to the limit as delta x goes to 0 of this function up here, f of x plus delta x, so x plus delta x squared minus 2 times x plus delta x plus 3, then minus, and now I need to subtract f of x, which is x squared minus 2x plus 3. Make sure you put your f of x in parentheses so you can distribute that minus sign through there. And that is all over delta x. And then what we always discovered on these is if we attempted to directly plug in delta x equals 0 into the problem, we end up with 0 in the numerator and also 0 in the denominator. So we're going to try to simplify this numerator and see if we can factor out a delta x to cancel with the delta x in the denominator. So the next step, let's do some multiplying out. Delta x goes to 0. When I square this binomial, I get x squared plus 2x times delta x plus delta x squared. Let me distribute the 2 here, minus 2x minus 2 delta x. Still have the plus 3. Then I'll distribute my minus sign into the parentheses, minus x squared, then plus 2x, and minus 3. And that's still all over delta x. We haven't done anything with the denominator. All right, now look at what cancels out. In fact, anything, when you do these, you'll notice anything that doesn't have a delta x in it will cancel out. I have an x squared here, and I have a minus x squared here. I have a plus 3 here and a minus 3 here. So everything else, oh, still have a 2x. I've got a minus 2x and a plus 2x. They're going to cancel out. So the only thing left are terms that have a delta x in them. So we could go ahead and say this is the limit as delta x goes to 0 of 2x delta x plus delta x squared minus 2 delta x. And that's still all over delta x. Now we still have the same problem we had before, which is if we plug delta x as 0 in, I end up with 0 over 0. But in the numerator, since every term has a delta x, we can factor it out. So I get the limit as delta x goes to 0 of delta x times, when I factor out delta x from the first term, all that's left is 2x. From the second term, we're left with a delta x. And from the last term, just minus 2. And that's still all over delta x. Now we can do some canceling. Since I've got a delta x factor in the numerator and denominator, that factor cancels out. So now I've got the limit as delta x goes to 0, and the denominator's canceled out, so it's just the limit of 2x plus delta x minus 2. Now we can substitute in directly. Delta x is equal to 0, and so we find the limit is 2x plus, substituting 0 for delta x, minus 2, or just 2x minus 2. And that is the derivative of the function. F prime of x is equal to 2x minus 2.